Aloha and welcome. In this video, we're going to be talking about WLAN standards. WLAN stands for Wireless Local Area Networks. So we're going to be talking about the 2.4 gigahertz band. We're going to talk about the 5 gigahertz band. We're also going to get into a lot of the terminology that we use. We're also going to talk about the legacy 802.11 legacy technologies, and we're also going to talk about the modern technologies that we use. So let's go ahead and dig into this. I want to use the book because the book has some really good examples. So I'm going to go ahead and throw this up. Yeah, so you can look up here. We've got WLAN standards. So we're going to start with the 2.4 gigahertz band channel. So the 2.4 gigahertz, it's a lower frequency, longer wavelength band used for WLAN. And the thing about this one, and I've mentioned this in previous videos, but this one has a lower capacity to carry data, but it reaches further than your 5 gigahertz channels. So 5 gigahertz is really good when you're close by. You can really get a lot of throughput. But as you go further away from it, and as you go through walls and things like that, it's going to drop off severely. So if you've got something that's across the house or something like that, a 2.4 gigahertz band is probably going to be better for you, given the distance. But there's a lot of things that you have to know about the 2.4 gigahertz band in order to successfully use it. So we're going to talk about that now. First of all, let's talk about the channel width. So the channel width is going to be measured in megahertz, and the channel width of 2.4 gigahertz is 22 megahertz. And that's calculated, the channel width here, it's measured as the distance between the channels starting RF and the ending RF. And you'll notice that when you look at the channels here, the channels overlap. So if you look at one, the starting, it starts at 2401 and it goes up to 2423, but the next one starts at 2406. So if you notice, there every five megahertz, we've got a new one starting. So if you're trying to use these, and let's say that you're using channel 1 and somebody nearby is using channel 2, you've got overlap. So you're going to see yourselves butting into each other. So there's only 3 different ones, well, 4 technically, but we only use 3 in the US. But there's 3 channels here that will be clear for you to use, and that's going to be the 1, 6, and 11. 14 is also clear, but we don't use that here. I think Europe doesn't use it. I think Japan is one of the few places that does use channel 14. But if you look here, it talks about channel overlap. Channel overlap is just the fact that, each one of these is, the 1, 2, 3, these are all overlapping. They're using the same area. So if you're in a busy environment, let's say you're in an environment where let's say you're in an apartment, or let's say you're in a dorm or something. If you've got wireless access going on and the guy next door has it and the person on the other side of you has it, you might be using the same, channels there. And if you're using the same channels, you might be butting into each other. There's technology out there that helps you try to find the best one by channel hopping until it gets a clear signal. But if you have it set on one particular one, you might find yourselves having a little bit of interference there. So anyway, that's channel overlap. And there's another concept out here called bonding channels. And bonding channels is when you take more than one channel and you combine them together, you bond them together to get more bandwidth out of it so you can pass more information. So that's called a bonded channel, and we'll talk about that a little bit more. Over here, it talks about 1, 6, and 11, 1, 6, 11, 14 don't overlap. But again, we only use, Japan is the only one that uses 14, all 14. So anyhow, here is a good example of the participation activity. It shows you the different the bandwidth. So the 2.4, it's going from 2.400 to 2.499. The IEEE 802.11 technical standards specifies 1422 megahertz wide channels. So that's 1422 megahertz wide channels. So if you hear the question on the test, which band has 14 different channels, that's going to be the 2.5, the 2.4. So at least 10 of these channels overlap with one or more adjacent channels. So here's a nice explanation of what we were seeing in the numbers up above. So you see that there's overlaps in each of these. So at least 3 channels do not overlap, and here they're marking them. So they're marking them as 1, 6, and there's, of course, 11, then 14 if we were using that over here. There, you see 1, 3, or 1, 6, 11, and oh. So nearby WAPs, wireless access points, use different combinations of the 3 non-overlapping channels to provide roaming and interference and avoid interference. So moving on from that, there's going to be some nice graphics here for you to try to tell which to fix certain ones like WAP 7 over here. What channel should you use? You see, you've got 6 over here, 8 over here. Or wait, no, channel 6, 1. What could you use over here? That would be 11 or 14. 14 if you're in Japan, but 11 if you're not. So yeah, so let's talk about the 5 gigahertz bands. So the 5 gigahertz bands, that's at a higher frequency, but a shorter wavelength. And again, these are not going to be traveling as far as your 2.4 gigahertz band. So this one, 5 gigahertz band has 25 channels. So keep that in mind. If they're asking about the 5 gigahertz, it's 25 channels. Each 5 gigahertz channel is 20 megahertz wide, and all 25 channels are non-overlapping. So very different from 2.4. All these are non-overlapping. So the 5 gigahertz channels are organized in various unlicensed national information infrastructure bands, that's known as the NII, and an unlicensed national information infrastructure, or U-NII band, is a band defined by the United States Federal Communications Commission, the FCC, for WLANs and wireless ISP. ISP is Internet Service Provider. So 4 U-NII bands are used in WLANs. That's going to be I'll just call it UNI for the sake of brevity, but UNI 1 is the UNI band, including the 5 gigahertz channels of 36, 40, 44, and 48. Notice that they're all 4 apart. So 36 through 48 here. Then you've got the UNI 2, which is going to be the UNI band, including 5 gigahertz channels of 52, 56, 60, and 64. Again, they're all 4 apart. And then you've got the UNI 2 extended, which is including the 5 gigahertz channels of 100 to 144, so the entire range there. And then you've got UNI 3, which is going to be the 5 gigahertz channels from 149 to 165. So you're going to need to know these. So it's good to know that like on the first ones, we're talking about there being 4 apart there. So you can also bond these together. So you can bond them together to make 40 megahertz because they're 20, but you can bond them, you can double it to 40, or then quadruple it to 80, and then you can double that to 160. So you can so if you're going to bond 2 of these together, you're going to like if you've got channels, if you want to bond 2 of them together, you're going to take the in-between number for the thing, and we've got some examples in here. So we don't have them right here, but if you look at this, so this is uniband 1. You see we've got 36, 40, 44, and 48. But if we were to go out here and we were to bond them together, we're taking these and we take the middle number. So the middle number for 36 to 40 is going to be 38. So we refer to this as channel 38, and this is going to be 40 megahertz width. So then if we were going to combine these all right here, the 36 through 48, we'd take 42 as the mid number here. So we take 42 as the name of the channel. So that's going to be an 80 megahertz channel. And then for 160, we're going to go right in the middle of all these channels, and we're going to take 50. So 50 would be a 160 megahertz channel. And then we've got 2A, it's broken up the same way. And then we've got 2C and 3 down here. So we also have good graphics that show how they're divided up. I'd recommend you go through this. This is really a nice demo of the 5 gigahertz band, or the 5 gigahertz, the band channels that we have in there. So go ahead and take a look at that. It's going to show you the numbering system and everything. Then we have our legacy WLAN technical standards, which I alluded to earlier. And these, if you look at standards, they're all marked with 802.11 and then the year that they were enacted. So we've got the 802.11 1997, That's the original 802.11 technical standard. And then they do additions. They roll up, as I mentioned above, it does a rolled up to maintain the interoperability with legacy devices still in use. So you always want to be backwards compatible. So we've got 802.11, 2007, 2012, 2016, 2020. So the three main legacy ones that we talk about in here are A, B, and G. So 802.11a, it had 54 megabits of bandwidth on the 5 gigahertz band. We had B, which had 11 megabits of bandwidth on the 2.4 gigahertz band. You ask yourself, why is it that the later standard had less bandwidth than the earlier one? And that's because B actually was released before A. A came after B. So B actually was released first. It had a lesser bandwidth of just 11 megabits per second. And then after that, we had 802.11g, and I can't tell you how many devices I have for 802.11g for when I was working in a Japanese company years ago. I still have small wireless devices here and there, and even old Linksys routers that are wireless access point / routers that used 802.11g. So the 802.11g, that had a 54 megabits per second bandwidth on the 2.4 band, and it was backwards compatible with the IEEE 802.11b standard. And we have a nice history of the legacy standards here that you can go through. Then we have our modern ones. So our modern standards are going to be N, AC, and X. So the first one, N, it gives you up to 600 megabits per second bandwidth, and it's going to work on both the 2.4 and the 5 gigahertz bands. You've got AC, and that's the standard that provides around 7 gigabits per second bandwidth on the 5 gigahertz band. And then AX is it provides about 11 gigabits of bandwidth on the 2.4 and 5 gigahertz bands. So when you think about gigabits, we're talking about bits and not bytes. So that's one thing to keep straight. Also, what you have to understand is there's interference and error checking and whatnot that goes on that the phrase your actual mileage may vary comes into effect here, because you're probably not going to get the full bandwidth there that you think you are. So if you go into it thinking, hey, I'm going to get 11 gigabits per second, you're a little bit mistaken on that. It's going to be fast, but it's not going to be, that's the theoretical max, in other words. And because all these names are getting a little bit unwieldy, Wi-Fi Alliance decided to dumb it down a little bit for us. I mean, I'm sorry, they made it consumer friendly. So 802.11n is called Wi-Fi 4. 802.11ac is called Wi-Fi 5. And 802.11ax is referred to as Wi-Fi 6 or Wi-Fi 6E. So in these new modern standards, we had new types of technology that came out. One, channel bonding. So that's going to be aggregating at least 2 adjacent WLAN channels. You can use that to increase your throughput on the network. And then we've got MIMO, which stands for multiple input, multiple output. That's going to be when you leverage at least 2 receiving antennas and 1 transmitting antenna per band to improve RF signal quality and bandwidth. And you'd think that, well, if they're using the same, if they're on the same, band, transmitting with different, antennas, aren't they going to be, interfering with each other? But they do it just slightly differently spatially so that it doesn't interfere. Then we have multi-user MIMO, so MU-MIMO. And MU-MIMO is an enhanced version of MIMO that it's intended to improve the RF signal quality and bandwidth on a device-by-device basis. So as your devices are communicating with like a router or a WAP, as they're communicating, they're going to improve based on the transmission and everything. They're going to work to improve the actual signal. So these are the 3 new technologies that came out in modern technical standards for WLANs. And we've got good examples here in the participation activity as well. And that wraps up this section. If you have any questions, feel free to ask. I'm always happy to answer. So this has been WLAN Standards. Again, 2.4 gigahertz band channels, which have several overlapping ones. We have the non-overlapping on 1, 6, 11, and 14, you do need to know this. That's very important to know. The 1, 6, 11, and 14, that's going to be on a test most probably. Channel overlap leads to interference. Bonded channels combining the channels for bigger throughput. Then we've got the 5 gigahertz band channels. Those are going to be 22 megahertz wide, or wait, I'm sorry, I believe those 20 megahertz wide. So yeah, 20 megahertz, 25 channels. You've got U-NII 1, U-NII 2, U-NII 2 extended, and U-NII 3. And you'll need to remember that those numbers are 4 parts, so 36, 40, 44, and 48. So there's only 4 of them in that U-NII 1. Then U-NII 2 has 4 as well, but it starts at 52, which is kind of right after U-NII 1 leaves off. And then in the next one, U-NII 2 extended, it's 100 to 144, which is a big jump there. And then U-NII 3 is 149 to 165. And just know that we can combine the channels. We take the middle number for the name of the new channel that we're talking about. Then we've got the legacy A, B, and G, and we've got the newer ones, which are N, AC, and AX. And we talk about the new technologies, which is channel bonding, the MIMO and the MU-MIMO. And that's it. Again, if you have any questions, feel free to reach out and I'd be happy to help you. Aloha.